Hi, I'm Marker Servito.
Joyce, Eddie De Vera,
Rick V. Carino.
Jesse and P. Eden,
Ice Jerry Villa.
Is Carmela Biandoliamos.
With Rancio Velasquez.
Christian Tabadero.
From Rooms 11D. Today, when you ask anyone to describe the shape of the Earth, they immediately tell you it is round. Of course, they mean that it's round like a ball, not round like a circle or a disc. To be more precise, we would say its shape is spherical. While today's discussions about the Earth's shapes and the arguments of the ancient Greeks. In 300 BCE, before Common Era, the Babylonians believed that the Earth to be shaped like an oyster. Much later, two Greeks, the philosopher Thales, 600 BCE, and the poet Homer, 800 BCE, though the Earth was a flat disk. As time passed, various other shapes were proposed, such as cylinder and the cube. As late as the 16th century, the Earth was described by Christopher Columbus as a roundish sphere. By 500 BCE, the Greek mathematician and philosopher Pythagoras declared the Earth's shape to be a sphere. He arrived at this determination not through scientific observations, but because he believed the sphere to be the perfect geometry shape, and the gods would only create a perfect world. Supported by scientific observations such as that of the silhouette of the Earth on the Moon during a lunar eclipse, Pythagoras' assumption eventually proved correct. By the European Middle Ages, most scholars accepted the sphere as the Earth's true shape, but many non-scientists still believed that the Earth was flat. With the coming of the Renaissance and the rediscovery of ancient Greek texts, the flat Earth theory reluctantly gave way to that of the sphere. Using a circle's diameter as an axis and rotating the circle 360 degrees creates a perfect sphere.
Why is it important motion in our life? Movement is fundamental aspect of life. Movement is more than just exercise and does not necessarily require effort. True, it does require action. Movement affects everything from circulation, digestion, to metabolism, to immunity also. With movement, our bodies regulate hormone activity, detoxify, and respires. For example, in which you travel moves, the air we breathe is in motion. The blood is and our veins is in motion. The heart is in motion. The universe is moving, and many more. That's all for today. Thank you.
Module 3, deep in. No, because when I aim the stream of water from one hose across the path of the stream of water from the other hose, the water collides each other in a way that when they meet at the center, it's like they bounce at each other, and this is in contrast when I shine one light beam such that it crosses another light beam. The two lights passes through each other unaffected. The two streams of water hose supports a particle theory of light since there is a collision happen between the two streams of water hose, but the light beam supports wave theory of light since the two lights passes through each other unaffected. Conclusion. I therefore conclude that light can behave simultaneously as a particle and as a wave, and this is what we call quantum mechanics. However, There has never been an experiment able to capture both natures of light at the same time. The result will always depend on what kind of experiment we are going to conduct.
Number 1. It took scientists a long time to reconcile the dual nature of light, which led to the idea of the duality of matter. To further see an evidence of this concept, try to observe the smoke coming from a barbecue drill. From a distance, you will see a wave flow of smoke going up. Guide questions. A. Look closely into it. What do you see? White-colored smoke coming out of the drill. B. Does your observation tell something about the dual nature of matter? Why? Why not? Yes, because the matter is moving, it shows the wave properties.
Number 2. Observe the colors on the soap bubbles on the surface of water. Guide questions. A. What do you see? The colors of a soap bubble come from white light, which contains all the colors of the rainbow. B. What property of light is exhibited? Interference colors on a bubble look brightest when there's white light shining on the bubble and a black background behind it.
An electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Electromagnetic usually consists of wire wound into a coil. A current through the wire creates a magnetic field which is concentrated in the hole, denoting the center of the coil.
The special relativity of electromagnets in our world. Magnetism relies on a relativistic effect. It works because there is no absolute frame of reference, as indicated by Einstein's first principle of relativity. Electromagnets only affect charged objects if they are moving. The theory of special relativity always an important role in our modern theory of classical electromagnetism. First of all, it gives formulas for how electromagnetic objects and the particular electric and magnetic fields are altered. Under a Lorentz transformation form, one inertial frame of reference to another. Electromagnetism is a branch in physics that deals with electromagnetic force that occurs between in electricity charged particles. The electromagnetic force is one of the four fundamental forces and exhibits everything. Fundamental and exhibits fields such as magnetic field, electric fields, and light. Magnetism relies on a relativistic effect. It works because there is no absolute frame of reference as indicated by Einstein's first principle of relativity. Electromagnets only affect charged objects because they are moving. As the charged object moves in relation to the reference frame of the electromagnet, it starts to feel the effect to length contraction. A phenomenon of special relativity of its moving electrons, causing the object to be attracted or repelled by the electromagnet. That's all for today. Thank you.
Our topic is all about expanding universe. Expansion of the universe is the increase in distance between any two given gravitationally unbound parts of the observable universe with time.
According to the theory, galaxies are not moving through space, but rather with space as it expands. The expansion of the universe implies that all of the matter of the universe was once concentrated in one place, which also supports the Big Bang theory. Based on large quantities of experimental observation and theoretical work, the scientific consensus is that space itself is expanding and that it expanded very rapidly within the first fraction of a second after the Big Bang. star. This kind of expansion is known as metric expansion. Astronomers theorize that the faster expansion rate is due to a mysterious star force that is pulling galaxies apart. One explanation for dark energy is that it is a property of space, and as a result, this form of energy will cause the universe to expand faster and faster. American astronomer Edwin Hubble and others discovered in the 1920s that the universe is expanding by showing that most galaxies are receding from the Milky Way, and the farther away they are, the faster they are receding. Apparent size is what our precise its size to be. Depends upon an angle, which can be measured in degree. As an object gets closer, the visual angle increases, so the object appears larger. As the object moves farther away, the visual angle decreases, thus making the object appear smaller. So that's how the object appears to be bigger or closer, smaller, farther away to be. The reference point from which the distance of a body is measured is called origin.
This all for today. Thank